All right, so for us to optimize for the Despot 1, which is a 2-point approach, we ran a lot of the information matrix simulations and put them through our Monte Carlo. And from those results, we found that the numbers were very similar to the original Despot, so we decided to increase our TR by a little bit. It gives us a bump in precision as the numbers increase to 2000. Now, we chose to do this because we decided to reach our goal, we need to introduce a third point or a third scan to expand upon the Despot 1 technique. So with a little bit more precision in these upper numbers, the doctor or the radiologist can decide whether or not to run this third scan or third point that we've decided to implement.
So when it was time to implement the third point or the third scan into our design, we examined how much signal information was going to be made available as a function of repetition time and third flip angle. And this is already with our optimized 3-point design already in place. The first thing that we found was that longer repetition time on that second repetition time provided much more signal information. And that was no surprise to us. But as repetition time has a direct correlation to total scan time, we wanted to keep a leash on that.
So modeling this third point was a little different than the first because we introduced 11-bird Markov algorithm, which is a minimization technique that includes the least squares fit. So we designed it for the T1 values from 2000 all the way up to 5000, which is really pretty high. And based on a large number of results from the information matrix or approximations, we ran it through our Monte Carlos again, and you can see by this graph our various best guesses that we ran through. And the bottom line, the blue one, is 11 degrees where we have the best precision all the way across the board. And our TR came out to be, we chose a TR of 25 milliseconds because with a decent resolution that we ran at the magnet itself here at Krasnov, it came out to a scan time of about 5 minutes for the third point and 10 minutes for the total scan, which is definitely acceptable. So to further make sure that our technique is better than running the Despot scan twice, which takes about the same amount of time as running our 3-point scan all the way around, we had to pit it against 3 versions. We have the Despot 1 in blue and the Despot 2 or Despot times 2 in green, which when you run a scan with the same parameters a second time, you increase the SNR by a factor of square root of 2. But as you can see, our 3-point scan in simulation has a great precision compared to the other 2 scan techniques.
And indeed, according to our model, we are essentially getting more signal information across the entire range from 500 to 5,000 milliseconds, and dramatically so past 2,500 milliseconds. Now it's time for our
Is that because you have the limit?
That's right.
That's part of it.
That's what we like.
Well, this is that.
I've been rapping for about 17 years, okay? I don't write my stuff anymore. I just keep it from my head, you know what I'm saying? I can do that. No disrespect. But that's how I am.
Here we've both been running it like 40 or 50 times, when in reality right here, this is the mark for 200. Yeah,
So we won't get everything. I mean, we're not going to miss anything if we run it.
yeah, we'll miss just that much compared to what we're losing right now, which is where our stuff is terrible.
People love to love.
Who you love is the kind trouble.
And they feel.
We're from the engineering building, is that MRI?
It's Presley.
Sorry about that, the skipping, that wasn't supposed to happen. Okay, so what we're looking at here is essentially calculated T1 values for despot, the original despot, and our optimized 3-point design on the rig. You can see, essentially with your naked eye that this image is characterized by a large degree of discoloration. And that indicates greater variation, greater deviation. And you can see that our image is characterized by a lot more uniformity and homogeneity. And what we did was we compared congruent regions of interest in both the 2-point and the 3-point. And when I say congruent regions of interest, I'm talking about these vials. You can see them here, suspended in gelatin. These vials contain a heavy metal called gadolinium, and they each have a specific T1. Then we analyze it.
So after the analysis, and we got all the data from the scans, when we compared the 2-point versus the 3-point, when the values of T1 were over 2,000 milliseconds, we had a 40% increase, which is what we set out to do. And if you want to even push that back even further, when it was over 1,000 milliseconds, we had a 15% increase.
And so, in summary, with our basic approach to our whole optimization was to first research and figure out try to figure out how the MRI works, which is pretty complicated. And then we simulated the despot signals, or figured out how to simulate the MRI. And then we started picking points and running optimizations, figuring out how they interact with each other and how they converge, and started using the information matrix and a couple other variants of it. And then we checked if it was a viable option. If it was, if we chose it as a possible solution. If not, we ran back to the simulation. We did that many times. And once we had plenty of possible solutions, we compared them all, selected them, and went to the MRI, got our results.
Any other questions?